Right, so I am live, period two, geometry. Today we're talking a little bit of mini investigation using the figures below. Answer the following questions using the similar solids below. Misspelled similar. That's probably why I teach math. Um, First off, if we want to compare the cylinders that are below and determine if they're similar in size, we've got to find their surface area. So each individual surface area. So the formula for surface area is surface area is equal to 2 pi r squared plus 2 pi r h. Because essentially what we're doing is we're finding the area of the two circles, that's the pi r squared, and then we're finding the circumference around and multiplying by the height. Essentially, it's kind of like you've got two cylinders and you've got a rectangle that's rolled up, is how we're finding that back part. So surface area is equal, now it's just plug and chug. So 2 pi times 3 squared plus 2 pi times 3 times 5. Let's go ahead and plug that into our calculator. Okay. I'm going to do this in terms of pi. On the first part here, I've got 18 pi. So 3 squared is 9 times 2 is 18. Plus 2 times 3 times 5 is going to give me 30. So 30 pi. So my surface area is 48 pi centimeters squared. And I'm going to leave it in pi. I just want to show you. Now, you could use the decimal. So 48 pi is going to give you approximately 150.796 centimeters squared. Yep. Since we're finding surface area, it's area, so it's squared. Good question. Question was, is this centimeters cubed? Because this is surface area, it's actually going to be square. The volume stuff that we talked about yesterday is the cube. And also we're going to determine the volume of the cylinders as well. I'm telling you though, I think that you should look at this here, pi, and I'm going to show you why whenever we compare them. So let's go ahead and find the surface area of the bigger cylinder, cylinder B. So I'm going to write my formula again. So 2 pi r squared plus 2 pi r h. And again, I'm just plugging things in. 2 pi times 6 squared plus 2 pi times 6 times 10. So surface area is equal to 36 times 2, so 72 pi, plus 60 times 2, so 120 pi. So surface area is equal to 192 centimeters squared. Again, you could also say, okay, plug it into your calculator. 192 times pi, it's going to give you 603.185 centimeters squared. Okay, but again, 192 pi is what we kind of want to work with, because what we're going to do is we're going to create a fraction or a ratio to determine what the scale factor is, to see what we kind of notice and what we can kind of tell about the similar solids. So let's take a look at, yep, sorry, question. Why is it 2 pi r squared and 2 pi r h? So why is it 2 pi r squared? The reason it's 2 pi r squared is because you want to find the area of the circle. So pi r squared is the top circle and pi r squared is the bottom circle, hence the 2 pi r. the 2 pi r is the circumference. You want to find one of the circumference since they're both the same and then multiply it by the height, because essentially if you can find the circumference, if you rolled that out, that would be your length and the height would be your width. So think of it as all a figure like this is essentially just two circles. So one circle and another circle, and then a big long rectangle. So in order to find that piece of that rectangle that is the length, it's the circumference of that circle because it's rolled up. Does that make sense? Okay. All right, so let's go to, that was a good question. I'm glad that it's on this video for those of you that watch this again to understand it. Determine the volume of the cylinder. So let's take a look at cylinder A. Again, volume in this case is our big base times our height. So we've got the area of the circle, so pi r squared times our height. So volume is equal to pi times 3 squared times 5. Volume is equal to 9 times 5, so 45 pi. Now again, this is going to be, because the volume is centimeters cubed. The last one was surface area. Area is centimeters squared. This is centimeters cubed. You can change this into a decimal if you want. I'm just going to leave it like this. You guys know you can plug that into your calculator, but I think it's going to be easier to see what the ratios are and what occurs, which I think is kind of cool. So volume of cylinder B, again, volume is equal to pi r squared h. So volume is equal to pi times 6 squared times 10. So volume is equal to 360 pi centimeters cubed. So notice how, before we start into C and D, I just want you to take a look at these cylinders. What do you notice about the radius from cylinder A compared to cylinder B?
It's doubled.
It's doubled. And what about the height?
It's doubled.
The height is also double. So by doubling the radius and doubling the height, okay, notice the surface area, 150 to 603. That's a huge difference. So what we're going to do is we're going to find the ratio of the surface area between the two cylinders. So we're going to start with the surface area of B. We're going to put that over the surface area of A. So that was 192 pi over 48 pi. So if you divide that out, the pi's disappear. 192 over 48 is 4 over 1. So think about it. That's really the same as 2 squared, which means the ratio of the surface areas are, well, they squared themselves. If you didn't look at it like that, think of it as when you double the radius and height, you quadruple the surface area. Which you'd think that it would double itself, but it actually makes it 4 times that amount, which is pretty cool. Now take a look at the volume even. When you double it, you think, okay, I double the height, I double the height, I double the radius. I should just double the volume. But in turn, if you take the volume of B over the volume of A, you end up with 360 pi over 45 pi, which is 8, or 2 cubed. So it's essentially the ratio cubed. So when you double the radius and you double the height, it becomes 8 times the amount of what you did. Or essentially, you are taking it to the third power. You're exponentially growing it, which is pretty neat as well. Okay, something to think about if you're ever working with those types of materials. I'm going to cut the video right now because